Hi, for this video, I want to take some examples about range and domain of functions. I already had a video on this one, which is somewhat a first part of this video, and I will call this the second part. So for the very first example, we want to find the range of this function f of x equals to 3 to the power of x. But what we need to do is to consider how to sketch this graph. If we know how to sketch this graph, then we could easily state what the range will be. So how do we sketch this graph? To sketch this graph, we know that we want to look at the intercepts first of all, which sometimes might be the y-intercept, the x-intercept. So is it possible we have the x-intercept, or do we have the y-intercept? Sometimes we won't have both of these. So for this particular one, we know that wherever your graph cuts the y-axis, x is always 0. So for the y-intercept, we make x 0. And then we will see that our 3 to the power of 0 will then be equal to 1. So we are sure that the y-intercept will be at 0, 1, which we can easily go back to our graph and note immediately. So we might choose that as the y-intercept, y equals to 1. The other thing is to then consider if there is an x-intercept. And we know that if our curve cuts the x-axis at any point, at that point y has to be 0. So we make y 0. In this case, our y is f of x. So we say 0 equals 3 to the power of x. And careful consideration will show us that no matter what x is, 3 to the power of x will never be equal to 0. And how do we decide that? We might want to consider where x increases drastically. Okay, so if we like, we could choose maybe a smaller value of x and say maybe 3 to the power of 2 will give us 9. And increase it and say 3 to the power of 3 will give us 27. And 3 to the power of 4 will give us 81. And you will see that as we continue to increase x, the value of f of x also increases to infinity. So as x becomes positive and continues to go higher, f of x also continues to increase. That tells us that our graph at this other end will continue to increase in this fashion, and it's going to continue to go up. So we could easily maybe find a trend in that sense for this end of our graph. However, for this other end, we need to consider what happens as x decreases and goes towards 0. We already know that this curve is never going to touch the x-axis, but what happens if it really gets close to the x-axis? And what we need to do there is to consider when x tends to negative infinity, and we might consider maybe when x is negative 2, and then decrease it and consider when x is negative 3. And we might even go as far as considering when x is negative 4. And then maybe we might look at what the trend is looking like. So when x is equals to negative 2, we have 3 to the power of negative 2. and just a little calculation there with your calculator will give you 1/9, which approximately should give us something closer to 0.1. And I put this dot up here to show that the 1 is reoccurring. And then if I consider 3 to the power of -3, it gives us 1/27. And a quick look at that should give us something that looks like 0.037. And then we might consider maybe 3 to the power of -4. And then a quick look at that should give us 1/81, which is approximately equal to 0.012345,679,01, and it continues. And we see that as x tends to -infinity, the value of f of x continues to reduce and tend towards 0. F of x tends towards 0. Again, we are sure that it never actually reaches 0. So this presses really close to the negative x-axis, but it doesn't touch it. So what we have is similar to that, and this is something you can verify by actually plotting the graph using any of the online graph calculators, or one that you might have on your desktop. Okay, so this is what the graph looks like. And now we need to just finish this example by considering the range. We know that this graph does not touch the x-axis, which means that we will say the range, even though it does not touch the x-axis, we know that it gets really close. So anything that is greater than 0 as far as the y-axis is concerned, and then we consider that upwards. So from the x-axis upwards will be our range, but we just need to state it that it never touches 0. And that is why you see that my inequality does not include 0. It is f of x strictly greater than 0, and that will be our range. For the second example, what I want to do is to reduce the domain of this particular example that we treated first. And instead of taking the domain to be the whole of the real number line, can we break that down a little bit and have something like the domain between -3 and 8. -3 and 8. So let's see how this affects what we did earlier. Again, it's good to mention that right there is our domain. Sometimes it's something that might be asked, so you could easily quote that as the allowance of x as the domain. However, how does this affect the range? This is actually easy compared to the first example that we already took. And the first thing you want to do is to look at what happens when x is -3. So as x is -3, you find that your f of x will be 3 to the power of -3, which gives you 1/27. And then we can consider when x is 8. When x equals to 8, then we have f of x will be equal to 3, or 3 to the power of 8. And that should give what we then have will be y to be 1/27. So it is pretty close to 0. And so we have something like that. And that point there, if you trace that to the y-axis, will be 1 over 27, if you like. And then when x is 8, 1, 2, 3, 4, 5, 6, 7, 8, for y to be 6,561. So we have something that looks like this, and that might be our 6,561. So if we now decide what the range is, what we need to do is to look at the lowest value of our y, which is 1 over 27, and then also look at the highest value of our y, which is 6,561. Let's see, range will be equal to 1 over 27, which is the lowest point on the y-axis. And remember, the notation will be different. So f of x, and then that is less than or equal to 6,561. In the next video, we'll be looking at more examples on range and domain of functions.